hope you all had a great weekend. In previous lesson, we introduced a volume. Today, we are going to introduce another important concept, which is called density. It's actually, I believe this is not new to all of you. You definitely learned this one from physics, and also probably in earth science, you saw this word too. Today, so what is density? There's many ways to define that, but before that, I want to give you a picture. So if you can see that, it's actually if you consider two objects, and density is actually the one described how many uh, particles is packed in a certain space, in a certain volume here, and the more particle compact in a given volume here, the more density it will be. And another example I want you to look is so probably you hear this before. If we put oil in the water, it will float just because the oil and water has a different density. So this kind of concept is actually, I hope it will help you to understand that. And the definition we can understand in this way is density is just a measurement of how much mass is in a given volume. So after reading this, a lot of students are going to be confused about this word. So mass is one thing some students might see is that same as weight. A lot of cases you can consider they are very similar, especially the weight is actually we talk about. If we only talk about the weight on Earth, then we can actually see mass and weight are very similar. However, if you really change the situation or change the surrounding, change the environment, if the gravity is different, so we cannot see the mass and weight is the same thing. So one thing I want to remind you, but so far, since actually a lot of real life situation we encounter is actually talking about the how much mass or the weight on the Earth. So we actually consider that they're actually the same thing only on this situation. So that's it. That's the thing I want to introduce for density. We are going to look at two examples and to actually discover the relation between that. But one thing I want to remind you is density, since we call is how much mass is given in the volume. So the relation between density, volume, and mass, which is this, which is density is mass over volume. We can change a lot of situation here. So if you know mass divided by volume is d is density, so that means mass is actually density times volume. And also another thing I want to remind you, meaning volume can also be getting by mass divided by density. Okay, so they are actually equivalent in a certain way, just the way we write in terms of find certain thing. If we need to find the density, we can use mass divided by volume. If we need to find the mass, we can use density times volume. If you need to find the volume without given measurement, for example, I know the mass, I know the density, you can find the volume. Of course, if we know the dimensions or of certain object, if this is regular like a prism or even composite figures, we can use that to find volume. But in this situation here, depends on what kind of information we have, okay? So let's check some examples here. The first one, a hemispherical water tank has an inside diameter of 10 feet. If water has a density, so we say the word density, of 62.4 pounds per cubic foot, and we need to find the weight. So as in this, since we're talking about the mass on Earth, we can actually consider that the same thing in this situation. So what is the weight of the water in the full tank to the nearest pound? As we mentioned before, the density is mass over volume. But since this one we talk about the weight, again, since we talk about the thing on Earth, we consider the same thing. So it's density times volume. So meaning if we need to find the weight I need to use a density, which is already given, and find a volume. However, volume is one we need to find. So volume, first we need to figure out, hey, what is an object we are talking about? How do it look like? The keyword here is hemispherical. Spherical. So if you look at this a little bit word check, the first part is this. So hemisphere. So it's actually hemisphere. It looked like a hemisphere. So hemisphere is half of sphere. We know sphere is 3/4 pi to the r to the cube. So this is it. And hemi is half of that. So meaning the volume into divided by 2 by original whole sphere. So all we need to do is plug in the value here. So what is a radius? Continue reading the information. Has an inside diameter. So diameter is 10, and we know the relation between diameter and the radius, which is half of diameter. So we divide by 2, which is 5. So we know the r is actually 5. All we need to do is plug into the values. 5 to the third power divided by 2. After that, this is our volume. So the final weight. The reason I didn't put it here because I prefer to type everything together. But if you want to break it down here, that's perfectly fine too. So the final weight, in this case, we just write down weight again. But please remember, if you search the difference between weight and mass, you will read more information regarding. And a lot of cases, we actually need to consider what our surrounding, especially if we're on the moon. The mass and weight are totally different things. So the gravity determines that. But anyway, for this case, we know the weight is the density times volume. So which is whatever the volume we have here times 62.4. So all we need to do is type everything together. So first is 4 divided by 3 times, again, we use pi, so when we round it, are not going to put, okay, so it's 4/3 times pi times 5 to the third power divided by 2. Okay, see, that's a mistake. It's not here. Divided by 2 times 62.4. Excuse me. So, final answer here is sorry for this part, is actually, so let's check again. It's 16336 and also nearest to the nearest pound. We just check the decimal here, which is 2. We are not going to round it, so the answer is 16336. So, and also the unit is pound. Okay, so that's how do we find the mass, or determining the is really depend on the given information we have here. So this is the answer for this one. Let's check the last example. The density of the American white oak tree is 750 kilogram per cubic meter. If the trunk of an American white oak tree has a diameter, again, we give a diameter, which is in the height, what is approximate number of the kilograms of the trunk. So even we don't see the word and number of kilogram, we know it's actually talking about the weight here. So we know probably we're going to use density, which is given, and find the volume. So the volume, again, we need to understand what is the object we're talking about here. The keyword is the trunk of the tree. So if you really look closely, it's not regular, but trunk of the tree is actually, we can imagine this is like, yes, you are right, it's actually cylinder. So we need to find the cylinder volume, and then we need to find the mass. We just need to multiply the density again, which is given. So the volume of the cylinder, we already know that, which is the area of the base pi r squared, because it's circle times height. So let's just break down what are the p's we know. Okay, so r, do we know that? We do know the diameter is 1.04. So all we need to do is divide by 2, which is going to be our r here. So it's going to be 0.52. Okay, so and also you can always use calculator double check. And also the height, do we have that? We also have, which is 8. So all we need to do is pi times 0.52 squared times 8. Okay, so this is our volume. So the final thing, in order to find the final answer, is actually number of the kilogram. It can be calculated by doing multiplication with density. Again, double check if they have like consistent unit. This is kilogram per cubic meter, and this is a meter, and the final answer is asking kilogram. So there's nothing we need to do for conversion unit, and we times the volume, so we write everything together. All we need to do is put it in the calculator, we will find the answer. This is the front. So let's clear this. So it's 752 times. So you can use a parenthesis here or not, because it's all multiplication. They will not change a single thing with order, times 0.52. But this time is a square of that, because pi r square times height. So this is a volume and times the density. Now let's check the answer, which is this. Approximate number, which is kilogram. So they didn't see exactly approximate number, so probably we are looking, so this one we are looking at the whole number here. We just need to check the number after decimal, which is 5. So we are going to round it to the 0, so the answer should be 5111, and the answer is kilogram. And that's it. That's our final answer. Okay, so that's basically how do we use the relation between density and volume and mass to find out the final answer regarding, depends on the situation. Sometimes we might have volume and mass, and in order to find the density, but as long as we have, let's go back to the very beginning, as long as we know the relation between density, mass, and also volume, we can just use, we can just choose whatever the formula we need to use and to find the certain quantity we are asking to, okay? And that's it. I hope this video is helpful. Everyone, please stay healthy, stay safe. See you soon.